Okay, welcome. In this lesson, we are going to look at rationalization of the denominator. This lesson will help you learn about rationalizing the denominator of said expressions, including how to rationalize the denominator of simple said expressions, and then extend these skills to more complicated said fractions. Now, what is rationalizing the denominator, you may ask? Rationalizing the denominator is where we convert the denominator of a fraction from an irrational number to a rational number. So when you have a said expression where the denominator is a said or an irrational number, then we have to rationalize it, and that is rationalizing. Why do we have to do that though? Well, when we simplify fractions containing sets at the denominator, it is usually more convenient to make the denominator rational so as to avoid division by a decimal. We don't want to find ourselves dividing our numerators by decimals or sets, and so that is why we rationalize. Alright, how do we rationalize then? How do we do it, knowing why it is important? Well, first of all, we have to simplify all sets where the need be. So if you are given an expression where there is a need to simplify the expression given, then we have to do so before even rationalizing. Then, after simplifying, we identify the said denominator and multiply it by both the numerator and the denominator. So, this particular rule goes for dealing with monomial expressions, that is, expressions where the denominator is just one term. Okay, when it is like that, then we take the denominator set and multiply it by both the numerator and the denominator to make it rationalize. Then, after multiplying, we have to still simplify once again if the need be. That is how we go about it for monomial said expressions. But if it is a binomial denominator, then we have to tweak the method a bit by taking the conjugate set and then multiply it by the numerator and the denominator. So when we find that the denominator of a binomial expression is a set, then we have to take the conjugate set of that denominator and then multiply by both the numerator and the denominator. You don't have to worry your head now. When we get there, we'll explain it in simple terms for you to understand. Alright then, let's take an instance. Take 8 over root 2 for instance. How do we rationalize this? We can find that we have a said expression as the denominator, and we said this is what we want to avoid, and so we have to rationalize. Now we rationalize by taking the denominator expression here and then multiply through by both the numerator and the denominator. That is what we said. So we take the root 2 and multiply it for both the numerator and the denominator. This is what we get when we do so. We take root 2, multiply it by the numerator, multiply it by the denominator, and that gives us this expression. We get 8 times root 2 over root 2 times root 2, which is what we have here. This multiplied this multiplied that. This has already been covered in a multiplication of sets, so if you don't know how to go about it, I strongly suggest you look at the multiplication of set video. Now with this, we get 8 root 2 over root 2 squared, because root 2 times root 2 gives us root 2 squared. Now we can simplify further by cancelling the square out so that we get 8 root 2 over 2. Now here we see that 2 can cancel 8 4 times, and so we get 4 root 2 as our final answer. And that is what we have here. 4 root 2 becomes our final answer. We can take a general route. In general, if we have a set in the form a over root x, then we take the denominator, which is the root x, and multiply it by both the numerator and the denominator like this. Root x over root x. Then we simplify this expression. We'll get a root x times root x squared. which simplifies to be a root x over x. That's our final answer. And so generally this is the approach we use. You take the denominator, multiply by the numerator and the denominator, and then simplify to have our answer. Great. Okay guys, I'm kindly entreating you to subscribe. If you are getting value from this channel, like the videos, make sure you comment anything you have on your mind, be it related to this question or any video you would want to understand, and also share to people who would benefit. Great. Let's look at some more worked examples under rationalizing the denominator of a monomial expression. If we have 1 over root 5, how do we rationalize it? We said we have to multiply by the denominator said expression. So we have 1 over root 5, then multiply through by root 5. So we have 1 times root 5 over root 5 times root 5. We just simplified this to be 1 times root 5 over root 5 squared. And thus we finally get root 5 over root 5 squared, which is root 5 over 5. And that is the final expression, because this is the simplest form we can get this in the set form. And if you look critically, you see that we have rationalized it such that now we don't have a denominator which is a set or a decimal. Great. Make an attempt to this question as well. 4 over root 3. Pause the video, go through it, and then we'll simplify it together. Okay, this becomes 4 over root 3 times root 3 over root 3, because this is the said expression we have to multiply through. Now we have 4 times root 3 over root 3 times root 3, and this simplifies to be 4 root 3 over root 3 squared. We know what becomes of this, becomes 3. So finally we get 4 over root 3 over 3. We have rationalized the denominator to be a rational number, and this is how we go about simplifying the denominator of a monomial said expression. Let's look at a more challenging question and see how we can go about it. 8 over square root of 32. If you look critically, you can see that 32 needs to be simplified first, and so we have to simplify that. And this is how we go about it. 32 is 16 times 2. 16 is 4 squared times 2, and that is what we have here. 4 squared times root 2 now becomes 4 root 2. And so instead of having 8 over root 32, we now have 8 over 4 root 2. Right. Now this is our said expression we have to multiply through. And so we multiply through by 4 root 2 over 4 root 2. Now 8 times 4 root 2 is 32 root 2. 4 8 is 32, and then our root 2. And then 4 root 2 times 4 root 2 is 4 root 2 squared. Alright. Now when you simplify this expression here further, it is 4 squared times root 2 squared. And 4 squared is this, and the root 2 squared here. Now this is further reduced to 32 root 2 over 16 times 2. 4 squared is 16, and then root 2 squared is just 2. Now, as it turns out, 16 times 2 is also 32. That is what we have here eventually. You can see that the 32 will cancel out, and so we eventually get root 2 as our final answer. This is how you go about rationalizing a set which needs to be simplified first. Alright, in the next video we'll look at binomial expression, where we have to take the conjugate set before we rationalize. Make sure you watch out for that video and then learn from that as well.